Voting Theory Class 6 Video 3. In this video we're going to talk about something called the Condorcet criterion. So in the previous video we mentioned what a Condorcet winner is. If you recall, a Condorcet winner is an alternative that can beat every other alternative in a head-to-head runoff. So it's an alternative which is preferred to any other alternative in head-to-head runoffs. And the surprising thing about this is that they don't always exist. Sometimes there are voting profiles, there are elections in which there just simply is not a Condorcet winner. You get these sort of cycles of preference. So like A beats B, B beats C, and C beats A. So there's a cycle and no one alternative can beat all the other alternatives. Okay, so this time we're going to talk about the Condorcet criteria. Let's move on to the definition. So we say that a voting system satisfies the Condorcet criteria if it always chooses the Condorcet winner whenever there is one. So what I'm saying is, of all the different types of voting systems there are, you say that it satisfies this criteria, this Condorcet criteria, if it always elects the Condorcet winner to first place if there is a Condorcet winner. If there isn't a Condorcet winner, then there's no criteria at all, there's nothing to do. But if there is a Condorcet winner, you insist that it wins. Okay, so let's examine this in more detail. The first thing I want to mention is not every voting system satisfies the Condorcet criteria. Some of them do and some of them don't. And if you think about it, how would you show that a voting system does not satisfy the Condorcet criteria? Well, to show that a voting system doesn't satisfy the Condorcet criterion, you need to come up with a voting profile where there is a Condorcet winner, but that winner is not elected to first place. So you need to find a voting profile that has a Condorcet winner and not all of them do, right, as we saw in previous videos, but that winner is not elected to first place. Okay, by the voting system. If you want to show that a voting system does satisfy the Condorcet criteria, this is a more taxing thing to do. If you think about it, what does it mean for a voting system to satisfy the Condorcet criteria? It means that whenever a voter profile has a Condorcet winner, your voting system has to elect that winner to first place. But there are infinitely many different voting profiles which have Condorcet winners, and you need to show that in each one of these infinite number of different voting profiles, the Condorcet winner is elected to first place. And that's a hard thing to do. It's a more abstract thing to do. It's often a lot easier to show that a voting system does not satisfy the Condorcet criteria than to show that it does satisfy the Condorcet criteria. So let's just do an example right here. So here's some voting profile, okay? And the first thing I want to think about is, does it have a Condorcet winner? So I'm going to consider a bunch of head-to-heads. In A versus B, A is going to get 5 plus 1 plus 16, which is 22. And B is going to get 14 plus 1 plus 2, which is 17. So A wins. Okay, in A versus C, A is going to get 5 plus 1 plus 14, which is 20. and C is going to get 1 plus 16 plus 2, which is 19. So A wins. And I could stop here, but for completion, I just want to see who would win in B versus C. So in B versus C, B would get 5 plus 14 plus 1, which is 20, and C would get 1 plus 16 plus 2. Which is 19. So B wins. But the important thing is that A won both the head-to-heads. A beat B and A beat C. So this means that A is the Condorcet winner. Okay, A is the Condorcet winner. And now I want to see, do the voting systems which we've examined so far, do they elect A to first place? Of all the voting systems we've seen so far, do they elect A to first place? So let's start considering them. First of all, let's consider plurality. Okay, so in the plurality, what happens? Well, A is going to get 5 plus 1, which is 6 top preference votes. B is going to get 14 plus 1, and C is going to get 16 plus 2. So B gets 14 plus 1, which is 15, and C is going to get 16 plus 2. So under the plurality, what's the social ranking? Well, it's C beats B beats A. Okay? So this means the plurality elects C to first place. Okay? But A is the Condorcet winner. So the plurality does not satisfy the Condorcet criteria. Okay? Because there is a Condorcet winner. The Condorcet winner is A, but plurality still chooses to elect C. So that means the plurality voting system does not satisfy the Condorcet criteria. Okay? And in general, you know, it's desirable for a voting system to satisfy the Condorcet criteria, because you sort of think if there is a Condorcet winner, that's an alternative that can beat every other alternative. Well, maybe that alternative should win, right? If there's a Condorcet winner, that's a pretty good choice for the overall winner. But the plurality does not satisfy the Condorcet criteria. So let's consider a different voting system now. How about the 2-round runoff? Okay. So in the 2-round runoff voting system, remember, you first consider how many top preference votes everyone has, and then you eliminate the alternatives, every alternative apart from the top 2. Well, we've already worked out how many top preference votes everyone has right here. So this saves us a bit of time. Okay, so we eliminate A, and now we calculate how many top preference votes B and C have. So if we've eliminated A, and we count how many top preference votes B and C have, okay? So B is going to have 5 plus 14 plus 1, which is 20, and C is going to have 1 plus 16 plus 2, which is 19. Okay, so this means under the 2-round runoff, the social ranking is going to be B beats C beats A. Okay, well, again, A is not the winner. Even though A is the Condorcet winner in this particular voting profile, the 2-round runoff voting system puts A in last place, which is definitely not first place. So the 2-round runoff does not satisfy the Condorcet criteria. Okay. The 2-round runoff does not satisfy the Condorcet criteria either. What's the next voting system that we have? It's instant runoff. Okay. Well, I don't actually need to do any extra work now because there are only 3 alternatives in this election. And when you have only 3 alternatives, the instant runoff is exactly the same as the 2-round runoff. So I know that the answer is going to be the exact same as the 2-round runoff right up here. So the instant runoff does not satisfy this Condorcet criteria either. Okay, the instant runoff does not satisfy the Condorcet criteria either. So far we're like 0 for 3. We've tested plurality, 2-round runoff and instant runoff, and we found that none of them elect the Condorcet winner. So none of them have the Condorcet criteria. Okay, let's continue with some other voting systems. And maybe I'll skip some steps to speed things along. So let's consider this agenda right here. Okay, well, we know that in A versus B, we worked out up here, we worked out right here, that A wins. So A goes forward, C automatically goes forward. And we know that in A versus C, right here, that A also wins. So A wins. So under the agenda, we know that the social ranking will be A beats C beats B. Okay. Let's move on to another one. How about the border? Well, I don't want to have to do all the arithmetic for you right here, so instead I'll just tell you the answer. If you work out the border count, you find that A has 42 points, B has 37, and C has 38. Right? This is the thing where you have 0, 1, and 2, and you work out the total number of points. Okay? If you do that, you should get these answers, which means that under the border, the social ranking is A, C, B. And finally, under the Baldwin, okay, well, I'm not going to do all the work for you, but you know how to do this. Like, first of all, you take the border count and then you eliminate the alternative with the fewest points. So in this case, that's B. So you'd eliminate B and then recount. And if you do that, you'll find that the social ranking is ACB. Okay, so what does this mean? Well, in all 3 of these voting systems, A is the winner. Okay, in all 3 of them, A is the winner. But does that mean that they satisfy the Condorcet criteria? Well, no. Just because in this particular example, in this particular voting profile, they happen to elect the Condorcet winner, that isn't enough information to conclude that they will always elect the Condorcet winner. Right? We can't conclude anything from this information. Like, it's true that in this particular example, the agenda, the border, and the Baldwin all elect A as the Condorcet winner, but we can't conclude that they will always do that for every voting profile which has a Condorcet winner. Okay, well, that's quite an extensive example, so maybe we'll wrap it up now. That's the end of this example, and that's the end of this video.